My dear students, we learn chemical reactions in chemical kinetics. That is the classification of chemical reactions. Chemical reactions are classified as slow, moderate, fast, ultra fast reactions depending on their rates and the time taken for reaction to take place. The slow reactions can simply mixed by the magnetic stir or by the hand. However, the fast reactions where the lifetime of the reaction is comparable with the mixing time. Reactions which go to equilibrium in a few seconds are the fast reactions. Examples, slow reaction between hydrogen and oxygen to give the water in the absence of a catalyst, that is the platinum catalyst, the twice S2 plus O2, it gives the twice S2O. Another, that is the fast reactions, a reaction of hemoglobin with oxygen and carbon dioxide. Organic substitution reactions like bromination of aromatic amines and the phenols. Some of the fast reactions, species involved and the rate constant. Species involved, for example, H plus OH minus gives S2O. Rate constant is 1.4 into 10 raised to 11 decimeter cube per mole per second. H plus SH minus gives S2S. Rate constant K is equal to 7.5 into 10 raised to 10 decimeter cube per mole per second. These reactions occur at the temperature at 25 degrees centigrade. The another reaction, that is the H plus acetate ion CH3COO minus gives the acetic acid CH3COOH. The rate constant K is equal to 4.5 into 10 raised to 10 decimeter cube per mole per inverse. The reaction is occur at 20 degrees centigrade. The NH4 plus OH minus, it gives the NH4OH. Rate constant 3 into 10 raised to 10 decimeter cube per mole per second. The protonium ion, that is H plus S3O plus or the H plus the benzoate ion, para-amino benzoate ion, NH2C6H4COO minus, it gives the para-amino benzoic acid, NH2C6H4COOH plus S2O. The rate constant 3.7 into 10 raised to 10 decimeter cube per mole per second. S3O plus NO2 C6H4O minus, that is a nitrophenoxide, gives the NO2 C6H4OH plus S2, that is the para-nitrophenol. The rate constant is 3.6 into 10 raised to 10 decimeter cube per mole per second. The reactions with rate constant K is equal to 10 raised to 1 to 10 raised to 11 decimeter cube per mole per second. The ionic reactions that are these, for example, the H plus OH minus, the equilibrium constant for that reaction, that is a Kf divided by Kr, that is Kf is a rate constant for forward reaction and the Kr is a rate constant for the reverse reaction. K is equal to 1.4 into 10 raised to 11 divided by 2.5 10 raised to minus 5. It gives the 0.56 into 10 raised to 16 is a equilibrium constant for the formation of the S2 from H plus and OH minus ion. The ionic reactions such as the neutralization of acid by bases and explosion reactions occurs almost instantaneously. Reactions which go to equilibrium in a few seconds are known as fast reaction. Fast reactions cannot be kinetically studied by conventional methods. The specific techniques have been developed to measure the rates of the fast reaction. Ultra fast reactions. These reactions were first referred as instantaneous reactions. However, no reaction is instantaneous because their rates can now be measured. The method have been developed to study fast and very fast reactions in a solution. The moderate reaction, the sampling methods are generally used to measure the rates of a moderate reaction. Continuous rate monitoring methods like spectrophotometry and conductometry are used for this type of reactions. The several reactions with moderate rates which can be conveniently measured using conventional methods, for example, decomposition of hydrogen peroxide (H2O2), the decomposition of HI, decomposition of N2O5 nitrogen pentoxide, hydrolysis of esters, formation of esters, etc. These are the reactions of moderate type of reaction. Type of reaction, rate constant and half-life of that reaction. Type of reaction, slow reaction, rate constant, K, that is a decimeter cube per mole per second, that is a 10 raised to minus 7 for slow reactions, and the half-life T half in a second, that is a 10 raised to 8 second, means about 3 years, that is the reaction occurs require the 10 raised to 8 seconds. The moderate type of reaction, the rate constant 10 raised to minus 4 to 10 raised to minus 1, the half-life 10 raised to 5 seconds, about a day, to 10 raised to 2 seconds, about 2 minutes. The fast reactions which has a rate constant 10 raised to 2 to 10 raised to 5, the half-life of that reaction is a 10 raised to minus 1 to 10 raised to minus 4 seconds. Ultra-fast reactions about the rate constant 10 raised to 11, and the half-life, that is a 10 raised to minus 12, that is the picoseconds, to 10 raised to minus 15 femtoseconds. Methods to study the slow reaction. The physical methods, pressure, partial pressure or density of a gaseous system, colorimetry, optical rotation, potentiometry, conductometry, polarography. Second, that is the conventional kinetic methods. The methods to study the fast and ultra-fast reactions. Flow methods, relaxation methods, flash photolysis, electron paramagnetic resonance method, nuclear magnetic resonance methods, etc. We learn the stop flow method. We study this method, that is the study of kinetics of fast reactions by stop flow method. The stop flow technique is used to determine the rates of the fast reaction. Flow method is a mix and shake method in which the reactants are mixed within a fractions of a second. Stopped flow occurs for the rate of a solution-based reaction to be determined in milliseconds and with a very small volume of reactant. Reactions ranging from a few milliseconds to hundreds of seconds can be studied with a stopped flow method. Initiate the kinetic measurement in approximately 0.5 millisecond. In the stop flow method, the reactant solutions are forced through jet into a mixing chamber. The reactant solutions are forced through jets into a mixing chamber. Then the mixing chamber is so designed so as to ensure mixing in a 10 raised to minus 3 seconds. Mixing is at a 10 raised to minus 3 seconds. Then the solutions are then passed into reaction vessel. Means that reaction that can be takes place in the reaction vessel. The flow is stopped suddenly and concentration are determined as a function of the time using spectrophotometric method. The time flow is stopped suddenly and concentration are determined as a function of a time using a spectrophotometric method. The precisely measured small volumes of a solution are the rapidly driven from syringe into a high efficiency mixer, that is a mixing chamber, to initiate a fast reaction. Syringes are fitted with suitable holes. The solution is forced into the mixing chamber through jets by means of a common drive mechanism consisting of an air-driven piston. That is, the syringe drive is used to force the solution. The solution mix then pushes into the reaction vessel, that is the observation cell, or it is called as optical cell, then enters into the stopping syringe whose plunger comes to rest against the fixed stop. The volume injected is limited by a stop syringe. the stop syringe with a plunger, which the stop syringe which provides the stopped flow as the solution fills the stopping syringe. The plunger hits a block, that is a stopping block, causing the flow to be stopped instantaneously. The back pressure generated when the stopping syringe hits the stopping block completes the mixing. The triggers the recording device, usually an oscilloscope. The reaction is observed in a stationary solution. The kinetics of the reaction can be measured in the optical cell, that is in a reaction vessel. The method of detection utilizes the ultraviolet or visible spectrophotometry. The technique works within milliseconds of combining two reactants, and observers can read the source, that is arc lamp, then monochromatic, that is a beam of monochromatic, then pass optical cell, and then the absorbance detector, that is a photoelectric cell, and absorbance, that is a photomultiplied tool also. Then the signal processor, and signal processor, there is a recorder. The absorbance or fluorescence signal at a specific wavelength is recorded as a function of time. By attaching an autosampler to the sample syringe, it is possible to analyze up to several hundred samples per hour. Absorbance, fluorescence, and circular dichroism are useful tools for monitoring kinetic changes in a millisecond of the chemical and biological systems. The changes in absorbance, fluorescence, or circular dichroism are recorded. A stopped flow instrument, couple in either a circular dichroism spectrometer or a fluorescence spectrometer, is often used in the field of protein folding to observe the rapid unfolding or refolding of proteins. The method first developed by Rupton and Hastridge are used to measure the reaction half time in the range from the 10 to minus 1 to 10 to minus 3 a second. Advantages of the stop flow technique. A small amount of reactant solutions are used. It is useful for reactions involving enzymes, as enzymes are not available in a large amount. Second, that the method is not affected by a rate of flow of reactant solutions, provided the mixing is proper. Then another that is advantage, a permanent record of the progress of reaction can be obtained in the form of a spectrum of absorbance versus a time. An important advantage is the possibility that a transient intermediate can be detected and their concentration can be measured. Means there is a possibility that a transient intermediate can be detected and their concentration can be measured. It is a advantage of the slow flow technique also. Application of stop flow technique method. The typical research areas include reaction mechanism, drug binding processes, and the determination of protein structure. A wide range of reactions can be investigated involving, for example, ligand binding, coordination reactions, chemical reactions. A research article that there is a study of enthalpy changes during reaction of myosin fragment with ATP, electron transfer, in an electron transfer kinetics module. The reaction titanium oxide photocatalysis of chromium 6 in aqueous suspension. It is a research article. The fluorescence resonance energy transfer or the optical signal fluorescence assay for measuring the polymerase elongation rates. It is article, research article. The fluorescence quenching of N-acetyl N-tryptophanamide, that is NATA, N-A-T-A, by N-bromosuccinamide, NBS. The protein folding enzyme reactions, research are the refolding of human lysozyme and hen lysozyme is a research article. The protein-protein interaction, protein ligand interaction. Other applications also of post-upload technique. Thank you.